Analytical procedures. So there are a number of different analytical procedures involved in a study design and in the study itself. So, first, we have the numerous descriptive statistics that we have been talking about. So, you have mean, right? Standard deviation, percentile distribution, and so on. Graphs, right? Time series graphs, scatter plots, different kinds of graphs, bar graphs for quantitative, qualitative data. These are all descriptive statistics, and we don't usually think of them as kind of inferential. But it is a little bit inferential, but it's not a kind of deeper inferential. So that's the some of the analytical procedures. And usually in a study design, you want to identify ahead of time with what kind of descriptive statistics you are going to need or want. Usually, some of the basic ones, well, N, what's your N? How many people or objects you're studying or things you're studying, and so on. And some of the other ones are kind of basic too, but you may want to think about also any kinds of graphs or visualizations you may have with your data. And then we start getting into the more inferential area, a deeper inference. And we've talked about proportion test, and then we'll also talk about test of means meaning mean here as in average. And essentially, we're kind of, we're thinking of distributions, and we're thinking how one distribution may be similar to another, and where our value is on a distribution, and make an inference about the probability of this value, the likelihood of this particular value in relation to the estimated distribution of values we can expect. And the rationale for this, the reason for this is that, once again, we're dealing with samples, and we want to make inferences about a population. It is conceivable, and also we want to compare the distribution of the samples with some other assumed distribution, and we assume that which we assume for the population. So maybe really this is the main idea here, really, is to see how the samples, uh, the information from our sample would play out if we were to sample the whole population. And lastly is multiple regression. And multiple regression is looking into how one variable impacts, or multiple variables. When we're talking about multiple regression, we examine regression with one variable, but usually uh, this is number one, number two, error. This is not ampersand. This should be more like alpha. No, I should have had eraser here. Boom. So this is more like A, intercept. So the idea is that we have multiple variables, and we want to see the impact that all of these variables have on one outcome of interest. And we'll talk more about this in the following slides. So let's take a look at the template of a study design you usually find. So first is the background. So what's the context that you're dealing with? And often the background may also have the uh, the rationale or motivation for your research. For example, if you're dealing with testing different information systems, you may say, in our organization or in our field, information systems are very expensive. They cost millions of dollars, and they may also lead to millions or billions of dollars in revenue. So We really want to test whether or not people like the system, because we don't want to spend millions of dollars on a system that people don't like. So we want to actually carry out a research with rigorous and precise methods. Then you will see maybe a theory, and of a theory also sometimes this will be kind of objectives, and this may have the hypotheses that you're concerned with. Hypothesis that you're concerned with. You may like lay that out here. Different contexts, different fields do things a little bit differently, but generally following the same framework. And then the methods. And the methods, there's a lot going on in the methods, and often it's the most important. So who is your population? What are you studying? Where's the data? How are you acquiring the data? Um, what are the, and by the data, what are the attributes of the data? And then also the analysis and the analytical procedures that we just have talked about. Are you just, is this an exploratory study? If it's an exploratory study, it's usually a descriptive study. You're just counting things, you maybe just some averages, maybe some graphs, and that's it. Or is there some other deeper inferential analysis you're also conducting? The results, you essentially just present the results of the analysis and of the data. And in the discussion, you relate. The discussion is interesting because it relates the results to the theory, relates results to the theory or to the hypothesis. And then you kind of bring up other issues as well here in the discussion, such as potential other factors, confounding factors, and so on. And maybe future research. We don't need to be much concerned about that here, but often also limitations. What are the limitations for your research? Maybe you had very few people in your study. Your study only had 20 people. I mean, can that be really representative of your 3,000 employees? So maybe you need more people in your research, and that could go in future research and so on. So here I have actual some example, two types of example methodologies that I wanted to go over. And it may seem a little bit complicated. I'm going to cite this paper here and have you look at it as well. But I really want you to understand that the value for the study and the reliability of the information does not just come from the statistical analysis. So it's not just, this is really not the most important aspect. In fact, is perhaps the least important aspect. It's the even though it's the one we're focusing on in this class and the one we are uh, learning to carry out, there are all sorts of other steps that are really important for us to make the information reliable and representative, and also potentially be able to draw out those causal inferences. So here's a study of the impact of the use of hydrogen peroxide to treat COVID patients. Impact of hydrogen peroxide to treat COVID patients, and they use a pretty standard medical methodology of experimental methodology. And there's subjects, which are the observational units, you may say, in the data, and the people you're dealing with or the things you're measuring and studying. And these are patients with COVID-19. There's also, they talk about a randomization procedure, right? Because you don't want to put, once again, this is an experiment. So as any experiment, you're going to have a treatment and a control group. Now, actually, some experiments don't have both, but this one does, and that's good. So you randomize the people, you put 20 people here and you put 20 people here. And why do you randomize between these two groups, the treatment and the control? Think about that. Well, you don't want to put all the healthy people in one and all the sick people in the other, because then you either not gonna, you're gonna definitely show that your medication works, or definitely show that it doesn't work, or make it much more difficult to show that it works, and so on. There's the intervention. In this case, is the use of hydrogen peroxide spray in the nose, and there's also some other. I think there's a gargle as well, but for example, there's one or multiple interventions, and this. And this usually the intervention is the cause for the thing that you're trying to address, which is, uh, COVID symptoms or COVID treatment. So usually the intervention is the cause, and then the your outcome of interest is what you're trying to address or you're trying to treat. There's the measurement information. So I've talked about this. So how are you going to, what are the variables and how are they going to be measured? So in this study here, they're measuring cough, whether the person has a cough or doesn't have a cough, and also the level of how much they have cough or different symptoms at different days. So actually, the number of days adds a new dimension here, which is important and complicates the study a little bit, but it makes sense in this case. And also the statistical analysis at the end. So in this case, it's going to be comparing the amount of days people essentially have coughs, right? So you have the treatment group. In the treatment group, if you had 20 people, people were coughing for, 3 days. And in the control group, what is the control group? Once again, the control group means this is placebo. Placebo controlled means that they don't have the treatment. They just get a pill of sugar pill. So 3 people out of 20 in the treatment group, I'm sorry, people in the treatment group were coughing for 3 days. So you got to think about what you're measuring. You're measuring proportion of people. Are you measuring the value of the attribute, and so on? We already dealt with proportions in our z-test, our test of proportions, and we're also going to talk about dealing with a t-test where we can actually see differences in the other numbers. So in statistical analysis, compare amount of days with cough in the treatment group. I'm making this up, the results here, but just so you understand, people were coughing for 3 days. In the control group, they were coughing for 3.5 days or 4 days. And then the statistical test, you see, is this a big enough difference? Is this difference statistically significant? Right? And that's where we'll apply the statistical analysis. But notice how much more stuff had to go on so this analysis actually makes sense to do. It's actually valid. Now, we're not going to do all of this stuff in this course, but I just wanted to bring to our attention how important all these aspects of study design is. And another one I wanted to bring up, and hopefully we can actually do this in our class. I'm not sure, but this is the multiple regression approach. And it's actually similar to the other comparison of proportions or comparison of means, but involves multiple variables. And we can loosen up some of the other characteristics about study design and protocol, because there is something of a controlling factor in the multiple regression analysis itself. We don't need to get deep into it, but hopefully you can get the main idea that, let's say, for example, we're interested in the factors that impact bee sleep. That's our research question. What factors impact bee sleep? We have some data about bee sleep. Here I just have 5 records, but let's assume we have multiple records. And yes, we definitely want to make sure that our data is collected in a reliable way, that it's representative. So if you just get some random bees, well, a few bees here and there, doesn't matter what method you employ, your information is not going to be reliable. So we do want to check our data. We want to make sure that we have representative data. It was collected in a proper way. And Here we have sleep hours. So how many hours the bee is sleeping. How do we know how much the bee is sleeping? I actually have no idea, but I'm going to look that up. But suppose you can measure how many hours the bee sleeps. You got the data here. You have whether the data has been exposed to pesticide, yes or no, binary data. You have data on how much amount of pesticide the bee has exposed to. Now, this seems very detailed information. I'm not really sure this is realistic, but let's say we do have data on the amount of data that each bee, right? This is each bee. This is one bee, another bee, another bee, another bee, or it could be bee colonies as well. We could generalize, and then your observational unit changes. But you have to know what it is, whatever it is. A region where the bee is, northeast, the west, south, midwest, and the type of bee. Is it a sweat bee, a carpenter bee, a honey bee? And then also the size of the bee. So we have all sorts of attributes here, all sorts of variables. And maybe we want to see how all of these factors or any of these factors impact the sleep hours. Because, yes, pesticide may impact the sleep hours, but also the region of the bee may impact the sleep hours. Maybe in the Northeast, they sleep less or more. Maybe different types of bees sleep less or more, and so on. So we need to include these factors and also control for these factors. And actually, when we use multiple regression, that that does happen. So in the multiple regression, what we can do is when we include all these variables together in the equation, and when we actually run the multiple regression, the the statistical tool already does a lot of the work for us, so we don't actually need to do the calculation. But we can include all of these variables in the equation. So we just add it there in the function, and then it, as we have seen before, this regression equation is an algorithm that is going to produce this slope, these b's here, these slopes, which give us the impact that each variable has on the outcome of interest. The sleep hours is this one here. So it's really a wonderful thing. There's of course limits, but the multiple regression approach enables us to include multiple variables into this equation, to this function, and then gives us the impact that each variable has on the outcome of interest, controlling, and yet is controlling for each of the other ones, which is also the amazing thing about it. So it gives us each individual impact, considering the impact of all of the other ones. Now, it's not foolproof, but this is another also kind of example methodology that we're going to come across in more detail later. So here, I just wanted to wrap up with a checklist for an initial study proposal that I want you to think about. So first, you got to have your background. What's the context? Are you writing or studying bees? Are you studying people using technology? Are you studying uh, countries, behaviors of countries or policies of countries? So a whole other level. Are you studying communities and so on? So the background, and what about the background, right? What about the community you're studying? What about the people? What about the employees? What about the bees? Hypothesis. I want you to be as specific as possible. Are you looking at differences between genders? Are you looking at the impact of poverty on education level in different communities? Are you looking into the how people think about different information systems differently, and so on? What's your data source? Does the data have the data that you need? If you find a data source that doesn't actually have the data, it's not really a data source, or it's not useful. Analytical methods. Are you going to do a proportion test? Are you going to do a multiple regression? Are you going to do a t-test of means, comparing means of different populations or different samples, and so on? And then, of course, what are some expected results? And I put this in the initial checklist here. You're saying, well, I'm not going to have results in the proposal, but I want you to think about what your results may look like and how the results relate to the hypothesis. And it's just to kind of tie everything back together. So you want to make sure that your data can be analyzed, and that the results of the analysis actually answer your question. And you may say, oh, that's obvious, but it's no, it's not obvious. It's not direct. And you may need to kind of rethink about the wording, so you make sure that the data that you have actually addresses the question that you have. And we'll keep talking about this throughout the course. But for now, that's it. See you next time.